Hi everybody, it's AJ again. And in this video, we are going to be talking about classes. Now, classes are an improvement upon structs in that they can do the same thing structs do, but they have more features, as we will see. But in this video, we'll be starting the basics of a class. So a class allows you to contain variables and methods to act upon those variables that define how a class works. Now, a class is a template or kind of a boilerplate for an object. And C++, if you've heard this term a lot, is known as an object-oriented language. And objects are definitely a big thing in programming, is that objects are something that allow you to interact with the world. And that this comes from the principle that an object is something that you can represent in programming that you can represent in real life. For instance, in programming, the reason we do programming is that I can do other things in real life with ease. For instance, I could make a system in my program that keeps track of all the students at Virginia Tech. And the way I could do that, like in a structure, is I could make a object that has all the things that I need to keep track of for each student. So I need to keep track of their ID number, their GPA, their age, how many years they've been there, their tuition cost, do they owe me money, do they owe me library books, things like that. I can keep track of that with the student. And then I could make a separate object. An object would be each object would be different because each object would represent a student, but the class would define what each student needs. And I'm going to go through an example, and I hope that becomes more clear as I go through this. So right now I have three files. I have my testing CPP file, as you see up top. I have my rectangle.h and my rectangle.cpp. And basically what I'm going to do here is we're going to try to make a class here. And I'm going to show you guys how to do that. The first thing I'm going to do is does it already know? It does already know. I'm going to define a rectangle.h file in my CPP file. I'm going to include it in my main file so that I can reference it later. And then in my .h file, I'm going to start defining my class here. If you don't have this if and def define or this end if, don't worry about it for now. It just basically what it does is allows you not to double define h files, because if you include the same h file twice in your main file, then that is an error, and those allow you not to double define it. But without further ado, let's start making a class. So you start the same way of making a class, the same way you start making a struct. If you haven't seen my struct video, I highly suggest you watch it. So I type in the keyword class, and then I give it something. As you can see, I have this file is called rectangle.h. So we are going to be making a rectangle object, or a rectangle class. And simply, what does a rectangle have? What are the properties of a rectangle? Well, we know it is a height and a width. So let's start out with that. So I do class rectangle, and then I start out with a left curly bracket. If I press enter, I end it with another curly bracket and a semicolon at the end. Do not forget about the semicolon. It's the same thing with a struct. You need a semicolon at the end, or that is a syntax error. That is a big beginner programming mistake. So please don't forget that. And so again, now I get to emphasize the difference between structs and classes, which is why it's good to know what a struct is. So a struct allows every variable to be public, and a class by default makes everything private. So what do I mean by this if you don't know what public and private are? Well, public and private are keywords in the C++ language. If you typed in private and public, your compiler, your editor should assume them as keywords. And so what private means is it's private. So it means that you can only see the things declared under the private inside your class. So I can only see them if they're declared within the contents of the class. I cannot see them outside of the class. And I'll try to show a better example of this at the end to make sure it's crystallized. But if I make a rectangle class, let's say I have an int, I have a width, comma, and a height. So I have two variables, just like I do in a structure, and they're both public. So what I want to do here is show you guys what I mean. And what we're going to do here is I'll show you guys a quick example. So I'm going to go to my main method. Notice I have rectangle.h included in my main file. And I'm going to make a rectangle object. And the way you do that is you give the type you defined, so rectangle, and then I'm going to say, I'll give it another name, I'll call it rect1, and then I'm going to put a semicolon, so just like I declared a struct. And basically what I'm going to do here is, so I'm going to try to do what I did in a structure and use the dot syntax to reference the width and the height. And I'm going to say width. So let me just print it out here. So do cout, and let's see if I get an error, which I should. And I get an error that says expression result unused. Width is a private member of rectangle. That is the big error. So width is a private member. So that means I cannot access the width because I'm not inside the class. I am outside the class. I am using this object that I made, but if someone else made an object, I could make it. For instance, a string is an object. You use a string, so you manipulate a string through the methods a string has. And so you do the same thing with, you're going to do the same thing with a rectangle, but I'm not allowed to access the width and the height of my rectangle. And that seems like, doesn't that, and when you think about it, that should be a good practice in programming. This is known as a encapsulation, which is keeping everything that must be private to yourself, not allowing the user to change anything. Like, what if I had a rectangle? What if I had a rectangle that was the size of my house? I don't want anyone to come in and be able to change that rectangle. I always want it to be that size, or maybe that's not the best example, but I don't want users to be able to suddenly change to do dot width equals 50 and be able to change, whatever I just made, because that isn't good practice. I want to keep all my things. But also, let's say, I can show you guys a better example. So let's say I didn't want, for example, I didn't want the user to change the height, but I did want the user to change the width. So if I wanted the user to change the width and not the height, I could make height private, but I could make width public, and that way I could use the dot syntax to do all of that stuff, even though I did not. So now I won't get an error, and I should be able to run this. And I ran it, and ooh, I got 50. See? Yay. So that's something kind of cool. But it's important to understand the difference between public and private, and that you can't access private variables outside of your class. But I'll try to make this clearer as we go along here. So again, I'm going to make both of these variables private, because that is good practice. And so I have this rectangle class, and I'm going to show you what the use of having of the public places. So where do we get to use public? Well, we usually define variables to be private, but methods to be public. And so we can define methods for just specifically for this rectangle. So what's a method for a rectangle? A method for a rectangle may be getArea. And getArea is going to return a getArea is going to return a integer. It's going to calculate the area, which is simply the width times the height. And so I have this getArea method, and so I'm going to define it in my rectangle CPP file, which I have in this file. And the first thing I'm going to do is I'm going to include. Is it going to recognize it for me? It is going to recognize it for me. I'm going to include rectangle.h, and then I'm going to define my method. So I'm going to do int, and then I need to type in this mumbo jumbo getArea, and then I need to define it. Okay, so here you can see I declared the getArea method header in my H file right here, getArea method, inside my class, not outside a struct like I showed you guys in the other video. I have it in the class as a public method, which means I can use it publicly. I can use it outside of this class. So then I defined this method. So what is the getArea going to do? It's going to return the width times the height of the object. And so as you can see, no matter I can have different objects, I'll show you, but it will always calculate the correct area because the area is always the same, but if the height and width are different, it will always make the correct calculation. So one thing I need to do is I have this rectangle colon colon here. These are two colons, they're not semicolons. Okay, and what this means is this rectangle colon colon is very important because it is telling the get area method. It is telling the computer that the get area method is corresponding to the rectangle object method. It is corresponding to this method within the rectangle class that I'm defining here. Okay, so I need that rectangle colon colon to be able to do that. And also I need to say it's returning an int and then return the width times the height. And even though I went on that whole tangent about how variables are private and public, it is okay for me to use the width and the height that I defined here because I am saying with this class pointer is that, hey, get area is a part of the rectangle class and it is okay, so I have access to all the private and public variables I may define. So I do have access to height and width inside this method, the get area method. Okay, so this is the get area method, and there was one other thing I want to do quickly is I want to define a constructor. So a constructor is what is called when I create my object. It's the first thing, and it serves as a way of it serves as a way as what you need to do when you officially create your object. For instance, right now I'm creating my object. I'm creating my object rect1, and there actually is a constructor that is already made for me, that is implicitly declared for me without me doing anything. But I kind of don't want that. I want a constructor that, for instance, let's say, makes me declare the height and the width when I create the object, because I don't want a rectangle with 0 height and 0 width, which would be a very bad practice. Or a rectangle with an unknown width and an unknown height, which is what is happening here because I'm not defining the width and the height. I don't have no way of doing that right now, actually. So this is why I want to make a constructor. A constructor will be called at runtime. And so all you do here is I'm going to define, you name your constructor the same name as your class. So I'm going to name it rectangle because my class is called rectangle. And then, so I'm going to make my constructor initialize the width and the height. And the way I'm going to do that is I'm going to say rectangle int, and I'm going to show you two ways to make constructors. And like that, so this is how you have your constructor. Notice I don't have a return type. I don't even have void. I don't even have anything. Constructors will never return anything. So it's already declared. As you'll see, they never return anything. So you don't need, and it's actually a syntax error to put anything after it. Okay, so you don't want to do that. You just want to have rectangle, which is going to be the exact name of the class, exact caps and everything. So I'm going to define my constructor up here. So I'm going to do rectangle colon colon, and this may be a little confusing. You always need the rectangle colon colon, and then I need rectangle, and then I still have the constructor because the constructor is the name of my method, and I'm going to call it int a, int b. And what am I going to do? I'm going to assign width equal to A and height equal to B. And so what is this doing? Okay, so this colon colon again is telling me that I am looking at the rectangle class, which is in here, and I'm looking at this method. As you can see, then I have the rectangle and its two parameters. And here is just another way of saying I don't need to give the parameters names. I don't need to say, you know, this is A and this is B, because I just need to tell this method header what variables I'm using, the type of variables, which in this case is 2 ints, and that's perfectly okay. But I need to define the names over here. I can name them whatever I want because it doesn't matter, because that's why I need to give it names, so I can use A as an alias in my method. In my constructor, it's called. So as you can see, this structure is going to be really helpful. So when I make this constructor, I automatically get a width and a height. So let me just test all this code out for you. Let me save everything. And so now I have a rectangle. It's giving me an error. It says no matching constructor for initialization. And that's because when I make another constructor, I get rid of the implicit constructor for me, the constructor that doesn't really do anything for me, but it's made for me so I can create an object. So now I'm going to declare my constructor like that. And so this is how you declare a constructor. You kind of call it, I'm doing a lot of things on one line. I'm declaring my object, which is of type rectangle, which I defined in my class. I'm naming it rect1, and then I'm passing in these variables to my constructor, which is a function. My constructor is a function, but it's what is happening when I create my object. And what's happening when I create my object, according to my constructor, which I defined, is that the first variable is getting assigned to my width, and the second variable is getting assigned to my height. So that is what is happening. So now I'm actually going to see out another method we made together. The first method, I'm going to see out rectarea.getArea. And why do I have these things? So now I'm going to run this program, and I'll move this bad boy up just so I'm not always doing that. Always save everything first. There is an error in my program. I believe I forgot these bad boys. And so I got 800, which indeed is 40 times 20. And let's see if I change this to 45 times 20. Would that be 900? I think so. We'll see if I know math. And yeah, I get 900. So as you can see, the program is dynamic. No matter what I change the values to, the area will obviously make the correct calculation. So I can make, so just to show you the power of defining classes, is I can create multiple objects with different rectangle dimensions and then use them intermediately, which is pretty cool. So I have rect2 here I defined, and then I could see out the rect2.getArea. And yay, I have 423 times 20, which is 460. So that's pretty cool. That's the way. So we made a constructor here that constructs the width and the height, and then I was able to do both of those things. And I was able to do that, but I'm going to end this tutorial with showing you guys what I think is the better way to do constructors. So this is the easy way to do a constructor if you come from another language usually, which most people probably watching this video have not done any programming, so it really doesn't matter what I'm saying right now. But if you've done another language, if you've done Java, most likely, this is definitely the way you do constructors. But there is another way to do constructors here. So I'm going to get rid of all that stuff I had within my curly braces, and I'm actually going to make my curly braces here. I'm now going to get rid of everything in the curly braces. And I'm going to put a colon, and then I'm going to do width. I'm going to do width surrounded by colons. I'm going to do height, and then do a comma. Oops. Height, and then I'm going to do B, and then I'm going to run this program, and I need a save all button here. I'm going to run the program, and I got the same solution. So everything ran even though I made that change. And so what this is doing here is this is actually the typical way that people do constructors in C++ that kind of know what they're doing. So what this is saying is that, sorry guys, I had to cut there. So what's happening is this colon stands for initializer syntax. And initializer syntax is what basically a better way to do this in C++. So when I had my old example here, I'll put it back in just these colons. So I had like height, width equals A. What was happening is the integer A was automatically being initialized to a default value, and then A was getting passed in to a width. And the thing about that is, you're taking two steps. You're initializing A to a default value, which could be 0 or something, or some random number, and then I'm finally making a 7 or whatever I passed in, and then that's getting assigned to width. Well, if ints and regular default variables, or int, chars, and doubles and floats are known as basic types, and they don't really take much time. They're simple bits and bytes in computational language. But let's say I was passing in another struct or another object into my rectangle object, which is totally possible. It could be a huge object, and initializing it and changing its values could take up huge memory and take up a lot of time. So instead of initializing the object, we want to pass it. We just want to use what we already have and pass that in to the width or the other object. So that is what we're doing with the initializer syntax. Let me get rid of this up here. We are allowing the object just to be passed in and look and copied over to the rectangle object so it can be used, and not to waste time initializing it and transferring it over. We can instead just transfer it over. So that's what's cool about initializer syntax. You can do either way if you want, but I would do it this way. Definitely if you ever got a job in C++, if you did it the other way, people would look at you and say, wow, do you really know C++, or are you just some Java programmer? And it's less code, right? You just do the width, you just do the name of the variable, colon, and then whatever variable names you gave these two guys. Whatever variable names, so it's still A and B. So I'm still doing the same thing. I'm just avoiding a step that could cause me that causes the computer a lot of time, something that you don't see. You have to think about, in programming, you want to think about, what's the most efficient solution. And the difficult thing is when you're beginning programming, it's really hard to think about all that stuff because primarily you just don't know how everything works, and that can be very confusing. So you're just focusing on getting your loops right. So yeah, so remember guys, when you declare a class, you want a semicolon at the end. Everything that's public is things that you want to use outside of the class. So like I want to use my constructor outside of the class, which means it's not contained within the rectangle definition, which is defined either by a rectangle : or inside the class rectangle. So for instance, the only things I can do inside my rectangle class outside in my main method, which is outside my class, is declare the constructor like I do here and call the getArea method. I can't do rec1.width something. It will give me an error, as I showed you guys in the beginning. Please give me an error now, computer. Yay! And it said width is a private member, so I can't actually access width, which is a good thing, because maybe I don't, once I initialize it, for my case, I'm going to say, I don't want my user to change it. And quickly, I'll go over this thing. If I wanted let's say I wanted my user to change the width, well, I could do a void set width method that takes in an int a, and basically, or I'll call it new width, and I'm going to copy that over. Notice I still have a semicolon, and I'm going to copy that over, and I'm going to do int, well, I'm going to do set width, and then I'm going to do it with the rectangle. Put the rectangle : say it's using the class, and then yeah. So then I'm going to do width equals new width, and you don't need to worry about. You only use this initializer syntax with the constructor. You don't need to use it with everything else. It's perfectly okay. But yeah, that's about it. But if you wanted to, you could do the same thing. You could do new width, and that would be perfectly okay. Oh, I'm sorry. It will not be okay, guys. I am being an idiot here. It will not be okay. You're not allowed to use it. That error just told me so. Okay, so you just want to do it this way because you can only use base initializers with constructors. I should just cut this part out. But yeah, see, I'm learning new things too. It's a great day in the neighborhood. Yeah, so like for instance, so I just made a method to be able to set the width. And I guess I'll demonstrate that, guys, to you. So I'll do rec1.setWidth, and I'll set the width to 1 now. So the width of rect1 is just 1. If this would freaking not do shit, so the area should be what, 20? Yeah, so the area is now 20 because I changed the width just through this method, which is good practice. So I could have a set width and a set height method, so I can't which is very good practice in programming, because I don't want the user to be able to change my variables, and maybe I only want the user to be able to change the width because I'm in a construction company and I can only change the width. I hope you guys understand the example. Comment below if you have any questions. I'll try to answer them. But yeah, that's classes, and maybe I'll make another video on more advanced things you can do in classes. But remember, there's initializers for syntax. You don't have to do it, but it's okay. And yeah, so guys, have a great day, and I'll try to make sure I know everything next time. Everyone have a great day.